So in number 1, answering homework that you guys did last night, we're talking about just at t equals 4. So if you went to your graph at t equals 4, you guys did a great job of seeing the y values, the velocities. The velocity at 4, the y value at 4 is a positive, hence the particle is moving to the right. But number 2 is saying over what time interval is the particle moving to the left. When's the particle moving to the left? Now, here's where it got a little tricky. I agree over 5 to 9. I agree with 5 and 9. But what did you put at 5 and what did you put at 9 as far as parenthesis or bracket? What did you put at 5? No, just look. Just what did you put at 5? Parenthesis or bracket? Parenthesis. And I totally agree. Why? Because what is the velocity at 5? 0. What's going on if the velocity is 0? The particle is still or stopped or at rest, right? So is it moving to the left at 5? No. It's momentarily stopped. But how about 9? Why does it need to be a bracket? Isn't the velocity negative at 9? You see it? Since they cut off the graph there. It's not 0. The velocity, I should say, is not 0. If we were to let time keep going, it would keep on moving to the left, so we have to include 9. Does that kind of make sense, guys? Is it seconds? Yeah. The particle, or Bob, is moving left during those times. Okay, number 3. At 4 seconds. So we're back at 4 seconds. Is the acceleration positive or negative? You guys can see the 4 seconds and the point at 4 seconds, the velocity at 4 seconds. How do we think about acceleration again? Yeah, that's one way. You can think of whether velocity is increasing or decreasing, or you can also think about what is the sign of the slope. The slope of velocity or the increasing, decreasing nature of velocity both tell me about acceleration. So, what's acceleration's sign? Negative. Good. Why? Because the slope is negative at 4 of velocity, or you can say velocity is decreasing at 4. Which one do you guys like better? Okay, so let's go ahead and use that then. Acceleration of the particle is negative. It could actually be super snazzy. Want to be super snazzy? A of 4 is less than 0. Wow, that saved a lot of time. Since V of t is decreasing at t equals 4. I'm not going to say V of 4 is decreasing because V of 4 is 1 point. I need to say V of t is decreasing to be proper, to be completely correct, because that's what I'm talking about. The function is decreasing at the split instant of 4. But that's good enough. Good job, good terminology. Velocity is decreasing, so acceleration is negative. Number 4, what is the average acceleration? Ooh, let's see what you guys did. Average acceleration. As soon as you see average, what should you at least somewhat be thinking? F of b minus f of a all over b minus a. But there is no f in this problem. I mean, there could be. I guess we could call it position. What's the average acceleration going to be? Average acceleration is going to be the average rate of velocity. Do you guys agree with that? Average acceleration is going to be the average rate of velocity. So who's my f in this case? V. And that's a good thing, because if it was anything other than V, how would we find it? So what did you guys get for V of 4? What did the values seem to be? On the AP, it'd be much more precise as far as like stating points so you wouldn't have to guess. But what does the value seem to be at 4? 6? Value, what does it seem to be at 2? 8 or 9? 9. Are you going to be smart and not lose points for silly reasons? Don't simplify. What are my units? Sorry, is it feet? I know it's per second. Meters? Which one? Feet. Show the computations. We did. Look. Dun, dun, dun. And indicate the units of measure. We did. No explanation necessary. Sweet. Why is Priscilla right? Wow. That's a first. How did that happen? Sorry, Patricia. What'd she say, though? It should be second squared because what are velocities measured in? And what's time measured in? Because isn't average rate of velocity, isn't average acceleration change in v over change in t? Or dv over dt would be acceleration? Thanks, Patricia. Feet per second, you could totally do that. And be like, ha-ha, you're not going to mess me up today. Or you could do feet per second squared. Huh? Yeah. You could do feet per second or feet per second squared. Either one. What's number 5? No? Why? What does that? What does that show us?
It shows that it's not continuous, so that means all you hear doesn't work.
Okay, pause. Let me back you up, Ryan. You're doing a good job. But go back to the word it. You said it is not continuous. Who's it?
The function on the interval from 4.
The function, so position?
Well, this is the graph of the velocity.
Okay. So the sharp point shows that velocity is not continuous. Do you guys agree? Why is someone saying no? You're doing a great job, but sharp points show that the function that's given, so velocity, is not differentiable. Does that make sense? Is there a point at that sharp point? Is there like a point there? You're just getting a little confused by what you're considering. When I asked, is there a point? That has to do with continuity. There is a point. There's no hole. They haven't stated that any of these values don't exist. Does that make sense? There is a point there. Like you could actually mark a point. There's not a hole there. So in the y values, there's a point. The point is at 3, what is that, 12? There is a point at 312. But will the slopes agree? Will the limit of the slopes agree at 3? There you go. That's what you're thinking. So the slopes disagree, hence the derivative does not exist. Hence the function is not differentiable. So I love the sharp point. I love that you saw the sharp point. The sharp point does prove that MVT does not necessarily apply, or MVT fails. But why were we even talking about MVT? Because a few of you guys are kind of like, what are they talking about? What does MVT tell me between the interval 2 to 4? And what does it have to do with this little -3/2 down here? Whenever they give me a time interval and say something about is there guaranteed, and they're talking about a derivative does point me to MVT, a guaranteed derivative value. MVT, we would say, MVT would guarantee the existence. Wow, the existence. ENC? E? Or ANCE? Exists? E, right? I don't know why I second guessed myself. I'm coming down with something. Okay. We can guarantee the existence of V prime of t. But why? Why -3/2? What's the big deal about that? Did anybody figure that out? Instantaneous rate would have to be the average rate. And what's the average rate on this interval? What's v of 4 minus v of... Wait, didn't we just find this up above? you actually simplified, the average is negative 3/2. So MVT would guarantee that. What am I going to keep going, though? But, good. But MVT fails on this interval since, how do you guys want to put it? Okay, don't say the function though, but say v of t, say who it is. But good, v of t is not differentiable where? You could say at the interval or just be specific. Or just say at t equals 3. Could you go on and keep on explaining and being like, since there's a sharp point, yeah, sure, why not? But they know, I know. If you say not differentiable, I'm assuming that you know what you're talking about because this takes a lot of knowledge to get down. So MVT would totally guarantee that instantaneous has to equal the average if it applied, which it doesn't. Okay. Is that cool? What did I just stop and tweak? I had to stop and tweak a few people on a couple different things. Did anybody catch something in common that I stopped and tweaked like 2 or 3 times? Saying it or the function. Because the function can refer to a lot of different things. It can refer to a lot of different things. And if you don't specifically say what it is, the AP guys will say, how do I know which one you're talking about? You could be talking about the wrong one, and they can't give you the point for the explanation. Does that make sense? Okay, so what do we have to be aware of? It. Okay, skipping number 6. Although, does anybody want to make a quick little guess at number 6? Did anybody have something down that they thought might be? For when or where? When? Is the particle farthest right?
When it's approaching.
Say it a little bit louder, Ryan. When it's approaching?
When it's approaching the sharp point.
No. Good thought, but where? 5 seconds is right. 5 seconds is right. Do you have like a way of explaining it, Nick?
Yeah, because like when it's moving in the right direction, it doesn't matter how fast it's going, it's always still moving right. So no matter how fast it's going, when it's at 5, it's still the farthest to the right.
Good. Wherever it originates from, like wherever the initial, they didn't even tell me where it started from. Like it could be starting, I don't know, 10 away from the podium. But either way, he's exactly right. For this whole time interval from 0 to 5, what's the particle doing? Maybe slower, maybe faster, but it's always going. And then what's it doing for the rest of the time? And we're going to learn, starting in section 4.2, but we're going to have to do a couple more sections, that not only can we know that it's going right for this whole time and then going left for this whole time, we can actually also find out from this graph how much it moved right and how much it moved left. Wait, that's crazy because how much, isn't that a change in distance? But this is a graph of velocity. Guess how we can tell? This area has a numeric value. And that numeric value is how much right it moved. And this area has a numeric value, but it's below the graph. It's change in position going left, so we would add, we would subtract, and we could know how far right and how far left. But that's another topic for another day. But good job, Nick. Yes, at 5, it's going to be farthest right, and you can kind of explain because it's strictly moving right. The particle. Don't use it. The particle is moving right from 0 to 5 and then moving left the rest of the time. It must be farthest right at 5. Did you guys like example 2 better or example 3? If you had to choose. Okay, never mind. We don't have strong opinions in this class. I forget. So, coming back to example 3. How'd you guys do in number 1? Or at least we don't voice them. Plug in 0 to what? To what? The velocity. And we have to find the velocity first, right? So to find velocity, actually, we might use velocity more than just right there. So maybe we'll find it here. Velocity is equal to, did you guys get 3t squared minus 12t plus 9? Did you keep going because you thought maybe it might be helpful to pull out the 3 and get t squared minus 4t up? There's supposed to be a t and a plus. Plus 3? Did you keep going because you thought it might be helpful to get t minus 1 and t minus 3? Anyway, velocity. What happens when you plug in 0? it's positive 9, right? So we can say, moving which way? How did you justify? Good. Because, now careful, you can't just say because velocity is positive, but you can say because velocity at 0 is positive. Good. Is that okay? You can use the word is positive, totally fine. But you need to either say v of t is positive at t equals 0, or just say v of 0 is positive. Number 2. Where did you plug in 1? Patricia said acceleration. Can you guys explain to me why she said that? And increasing, decreasing points to the quantity's derivative, right? So acceleration is going to be 6t minus 12. You guys good? Sweet. So what was a of 1? Positive or negative? Yeah, negative 6. So we can say, I don't want you to say it wrong, and I don't want to just give you the answer. How'd you guys answer the question? The velocity is, I'm writing down what AJ said, decreasing. Patricia was backing her up. Do you guys agree? Perfect. Good? How about number 3? We talked about this in homework yesterday. Did it stick? Find all the values given an equation for position for which the particle is moving to the left. Does this sound like solve for 1 or solve for an interval? Solve for an interval. What have we done this year, including yesterday? What did we review, remind ourselves of, where we look at intervals and signs of things? Sign charts, number lines, right? Who am I looking for? The signs of particle moving left. Signs of velocity. The signs of velocity will tell me the left or right of position, right? Do they give me a beginning, end? No. So negative infinity to infinity. Who am I putting in my number line? Critical numbers. And where do the critical numbers come from? Zeros of velocity, right? So I can say v of t is equal to 0 at t equals 1 and 3. So I can put down my 1, I can put down my 3. And this one, they actually aren't asking me to justify. If so, a number line will never justify. A number line only allows you to consider or think through. You would have to put words to what you did in the number line, like I'm doing here. Since 1 and 3 are zeros of velocity, and then I would go ahead and plug and chug. Or I guess we're not doing relative extrema. Never mind, they wouldn't really make me justify this one. But when you guys plugged in, I just covered my function. What ended up happening? Do you want me to double check you? Yeah, if you plug in 0, that's a positive, right? Plugging in 1, no. Plugging in 2, that's a negative. Plugging in 4, that's a positive. Oh, double check. Plugging in 4 minus 1 positive, 4 minus 3 positive, times 3 positive. Yeah, there we go. So when is this moving to the left? Good. What do you guys think? Open, closed, half open, half closed? Why open? I agree.
Equals 1 and 3, then it turns into 0, and then the function.
Perfect. If the velocity is 0, it's stopped, not moving left. Does that make sense? Sweet. Why aren't we doing number 4? Because distance goes back or necessitates us taking an integral, which we could do, but this is a bounded integral. Bounded integral? We haven't done bounded integrals. All we've done is indefinite integrals where we didn't have bounds, where we didn't have beginnings and endings. Hence why we're not going to do number 4 quite yet. Plus, total distance traveled is a little bit different than displacement. Oh, more physics, but don't worry, not for today. I want you guys to turn in your packet to the next page. Yeah, I know. We're not done. Nick, this comes back to your question. I think it was you about acceleration the other day. Was that you? That was not you. Someone asked me about acceleration the other day. It might have been period 6. Period 1 or period 6. Speed increasing, speed decreasing. If I were you, grab out your notes. I want you to get out a color pen, a highlighter, something, something, something. The AP loves to ask about speeding up, slowing down, or they could say speed increasing, speed decreasing. Means the same thing, but how you find it, this is where your experience with your car is going to get you in a little bit of trouble. Whether you drive a car or someone else that you know drives a car and you ride, way. Your familiarity with a car is going to make this a little bit confusing. But if you think about the numbers, this will make sense. If you think about the numbers, this will make sense. I would highlight speed increasing / decreasing, aka speeding up, slowing down. Very common concept, speeding up, slowing down. Speed up, slow down, sure, yeah, got it. Mathematically speaking, if we're talking about velocity, which is sometimes positive and sometimes negative, positive numbers just mean moving to the right, and negative numbers, negative values for velocity just mean moving to the left. So can you have something going quite fast with a negative velocity? Yeah, it's just going fast to the left. I'm going to go ahead and fill in the blank first. I'm going to quickly explain it, and then we're going to go to the packet and see if we can kind of flesh it out and figure out when it gets confusing and when it doesn't. The long story short is you're always going to be speeding up, aka your speed is always going to be increasing when velocity and acceleration, aka have the same sign. You're always going to be speeding up. Speed is always going to be increasing when velocity and acceleration have the same sign. Some of you might be thinking right now, wait, you could do a sign chart of the first derivative, velocity. You could do a sign chart of the second derivative, acceleration. And we could put them on top of each other, kind of like we did with CalcAB and increasing, decreasing. Maybe we have to do sign charts of both. Which is weird because you would think speed only depends on velocity, but it doesn't. Speed increasing, decreasing, some of you would think it only has to do with acceleration, but it doesn't. We need them working together in order for your object to be speeding up to the right or speeding up to the left. So what do you guys think this one's going to be? Speed's going to decrease, you're going to be slowing down when? You have different signs for velocity and acceleration. Might seem like it shouldn't be that big a deal. Like, okay, same signs, different signs. What's the big deal? Why is this so confusing? Well, I just mentioned the fact that we're going to have to do 2 sign charts. Why am I boxing it? So forever. I think we're on forever number 28. We were at 26 at the end of first semester. 27 was integration rules. 29. Oh, antiderivative. Good, good, good. Antiderivative, then integration rules, now speed increasing, decreasing. Okay. Let me try to illustrate this real quick before we go to the motion packet. I'm going to have like a visual representation of Bob the particle. Cool? Here's Bob the particle. Technically, he'd be more like this. Actually, he'd be more like this because he has no space. But oh well, that's okay. Bob the particle. Okay? What's the sign of his velocity if he's going this way? Negative. What would make him speed up? If acceleration, and it's a force that's changing his velocity. Sorry, he was stopped there for a bit. If he's moving to the left, his velocity is negative. Which way does the acceleration need to, in a sense, thrust him or push him in order for him to speed up? To the left. Okay, so velocity is negative and acceleration needs to push to the left. What do you think that makes acceleration's sign? Negative. Why is that weird? Velocity is negative and decreasing. Slowing down. No. Velocity is negative and decreasing. Acceleration negative. Guess what actually is going to happen? Speed up. What's little Bob doing now? But what if acceleration is a negative? Hence, it's, in a sense, maybe not stopping him. It depends on how strong the acceleration is against him. What's going to happen? Slowing down. So if velocity is positive and decreasing, he's slowing down. But what's different with velocity negative and decreasing? Speeding up. What if velocity is positive and increasing? Acceleration is positive, speeding up. What if velocity is negative and increasing? Slowing down. Do you see? But why is that weird? Whenever you hear velocity increasing, you're like, oh, he must be. But it's not necessarily speeding up. Velocity decreasing. Oh, he must be, but it's not necessarily slowing down. Depends on whether they're working together or whether they're working against each other. So, in your motion packet, I want you guys to peek out. We're going to go kind of fast through these. Worksheet number 3. I think it's the next page. Does that sound right? Cool. Just super basic. We're talking about speed. Speed is the absolute value, as in the motion concept, not the other one. Speed is the absolute value of velocity. It tells you how fast something is moving without regard to the motion. Sorry, the direction of the movement. What does absolute value always do? Make them positive, right? Make them or keep them positive. Why am I saying make them or keep them? Because make them, the negatives flip. Keep them, the positives stay the same. What you're dealing with. And if you guys remember piecewise functions, I know this has been helpful to remember that negative numbers will flip signs with absolute value and positive numbers will stay the same. Effect is taking the absolute value of a graph, of an entire function, I should say, have on its graph. If you take the absolute value of y equals f of x, I guess we could say absolute value of y, absolute value of f of x. Can any of the y's ever be negative? No. So any place or for any time interval where the graph was negative, guess what happens? There's a vertical reflection across the x-axis. So any places where the y values are negative, the values flip. Kind of like a pre-cal review. So cool, kids. Let's go ahead and do this guy together, then I'll set you guys loose for just a couple minutes to do situations 2 and 3 and 4. This is just an example. This is an example of a possibility of a velocity graph at t equals 1, 2, 3, 4, and 5. The velocities are 1, 2, 4, 8, and 16. You can make a function out of it, but don't stress. It's really just powers of 2, so I think it's 2 to the x. That would make sense. No, 2 to the x minus 1. Anyway, if the velocities are 1, 2, 4, 8, and 16, question, what would the speeds be if speeds are just the absolute value of velocity? Numerically, what would they be? Oh, that's silly. Yeah, positives stay the same, no big dealio. In this situation, velocity is, what would you guys say, positive or negative? Positive because the values are positive. Positive because the values are above, right? So positive and increasing. The positives are getting higher. Because velocity is increasing, what do we know about acceleration's sign? Positive. Velocity is positive, acceleration is positive. Look at the speeds. What's happening? Speed is increasing, aka I'm speeding. It is speeding up. Does that make sense? Take a second. You and your groups try to do situations 2, 3, and 4. Go. Oh, sorry, graphing speed. I think that's part of it. Speed would be like this, right on top of velocity. Okay, now go. Hopefully you guys figured out that this is going to be absolute value of velocity. 1, 2, 4, 8, 16, which means actually flipped from velocity, which maybe would have already told you increasing. But did you see what's going on? Velocity is negative and decreasing. Because velocity is decreasing, acceleration is negative. What's true about their signs? They're the same, which is why the object is speeding up. Which is why the object is speeding up. Speed. This one, you guys did the absolute value. 16, 8, 4, 2, 1. Velocity, once again, is negative, but this time it's... speed is decreasing, I agree. But what's velocity technically doing? Yeah, because the numbers are getting higher, which means closer to 0, which means speed. Velocity is negative and increasing. Because velocity is increasing, acceleration is positive. What's speed doing? Decreasing. Velocity is technically, numerically, the negative numbers becoming closer to positives. That's an increase in velocity, but a decrease in speed. Weird. Situation number 4. This one, the positives stay the same again. Speed is the exact same. Speed is decreasing, but what was going on to get you there? Velocity, positive and decreasing. Because decreasing, velocity decreasing, acceleration is negative. The signs, once again, did not match. Speed was decreasing. So when was speed increasing? I think it was situations, was it 1 and 2? Speed was decreasing in 3 and 4. 1 and 2, the signs were the same. 3 and 4, the signs were opposite. Ready, set? Put some sort of book or binder or something or others on top of your packet. Put something on top of the packet so you can't see it. Otherwise, take one, fill in the blanks. It's either increasing, decreasing, positive, or negative. Let's see how you do. The answers are either increasing, decreasing, positive, or negative. The blanks are either increasing, decreasing, positive, or negative. Okay, if you guys look at the backboard, what did you do Tuesday? Finish the speed increasing, decreasing quiz. And you, my advice would be don't discuss it with anyone. Take your time. You can even look at your packet if you want. Finish the quiz. But what else is due on Tuesday? I'm going to save on your section 4 notes. I want you guys to set up your notes. Set up your notes so that we can fly on Tuesday. Sound good? Yeah. All right, see you guys later. Alligators after a while, crocodiles.